Welcome to All This Math. This is Professor Parker, and today we're talking about geometry. And more specifically, we're talking about the Tangent Radius Theorem. And one of the things I like about geometry is that once you know the theorems, or the corollaries, or the postulates, you then just take those rules and that information, you just apply them, and then use it to solve the problems. So once you know the rules, you can come up with the answers. All right? But you also need to know how to do some algebra too. Or some algebra also, I should say. And I'm going to demonstrate that in this particular example. So as I said, the tangent radius theorem. Some people call this the ice cream cone theorem, because you'll see questions where you'll have diagrams, you'll have like a circle, and then you'll have these two line segments that meet at a point. All right. In this particular problem, these two line segments, VU and TU, meet at point U. All right. Now, there's some information that we're given. We're given the fact that segment TU is a tangent to circle C. This is segment TU. It's a tangent to circle C. And this is circle C. And I know that it's called circle C because I see this letter C near the center point of the circle. And we also are given information that segment VU is a tangent to circle C also. So here's segment VU, right? And this is still circle C, right? So, all right, now, what is a tangent though? I don't want to just throw terminology out at you. What is a tangent? A tangent is a line or a line segment that touches a circle in exactly 1 point. Not 2 points, not 3 points, but exactly 1 point. A tangent touches a circle in exactly 1 point. So segment TU will touch this circle at point T right here. Segment VU touches the circle at point V right here. Now, another thing that we know is that if the two tangents extend to this point and if the two tangents extend to a point that's external to the circle, that they must be congruent. So I want to label them as congruent. This is how we do that. Boom, boom. So they're congruent. All right, now, what else do we know about the tangent radius theorem? The tangent radius theorem tells us that when a tangent touches a radius in a circle, and before I go on, what is a radius? A radius is the distance from the center point of a circle to the edge of the circle. So CT would be a radius. CV would be a radius, right? So that's a radius, and this is a radius. It does not matter. It does not matter what the measurement of this is right now. All right? Just know that this is a radius. But when a tangent connects with or touches a radius within a circle, it forms a special angle, a right angle. So we can label that. This tangent connects with this radius, it forms a right angle. This tangent connects with this radius, it also forms a right angle. So now I have two right angles. Now, our goal, which is what I should have said from the beginning, is to solve for this angle. What is the measure of this angle? This is x degrees, right? So we want to say x equals what? All right? So now, what we want to do is we want to create an equation that we can then write down and then use to solve for x. Now, look at the shape that we have here. We have this tangent, this radius, and this radius. How many sides is that altogether? That's 1, 2, 3, 4. That's 4 sides. So we're dealing with a quadrilateral, all right? Now, there's some things that we know about quadrilaterals. We know that the interior angle sum of any quadrilateral is 360. How do I know that? This formula. The interior angle sum theory says that we can use this formula to find out the interior angle measurement of any polygon. And in this case, we're talking about a quadrilateral. I know we started out talking about circles, but inside this circle, there's also a quadrilateral. See, 1, 2, 3, 4. That's 4 sides. All right. So in this formula, n is 4 because n represents the number of sides. So we have 4 minus 2 times 180. All right. And then we just do the calculation. We do 4 minus 2, we get 2. And we do 2 times 180, we get 360. So that means that the total angle measurement or the sum of all the angles inside this quadrilateral is going to be 360 degrees. So what that basically means is if I take this angle plus this angle, which we know is 121 degrees, plus this angle, all four of those angles should add up to 360. All right? And since we know that, now we can create our equation. So we just go back and we just write out our values. So this angle is 90 degrees. So I write 90 degrees plus this angle, which is 121 degrees, plus this angle, which is also 90 degrees, plus this angle, which we don't know, but it's going to be part of our equation. They all add up to 360. So now we're going to solve for x, and what did I leave out? I left out my plus sign. Got to have a plus sign there, because without that, that looks like 90x. And we're not multiplying 90 degrees times this angle. We're not doing that. So we want to combine like terms. We do our addition. 90 plus 90 plus 121. So 90 plus 90 will give us 180. And then 180 plus 121 will add up to 301. So we have 301 degrees plus x equals 360. That's Kwame, if you were wondering. So 301 plus x equals 360. And then we want to solve for x. We have one last step. We just subtract 301 on the left and subtract 301 on the right. So we got x is equal to 59 degrees. All right? So x must be 59 degrees. And this is how you use the tangent radius theorem. And there are a lot of theorems in geometry. But if you understand what they mean and you get enough practice and do enough problems where you have to apply them, then you'll naturally start to memorize them. And then, where you going, bro? You naturally will memorize them, and then you'll be able to solve any problem. So don't let the geometry overwhelm you. As long as you know the theory, right? And as long as you do practice problems, right? And as long as you have somebody show you how to use them and which theory to use, then you should be fine. And this, as I said, is the tangent radius theorem. Some people call it the ice cream cone theorem because that looks like the ice cream cone, and this looks like it could be the ice cream. All right? Thanks for tuning in. Hopefully you learned something. Please continue to send your math problems to the All This Math DM, and we'll see you soon. Peace.